This video is going to cover division of polynomials. We are first going to start by dividing a trinomial, or a polynomial, by a monomial. And in this example, it's a trinomial because there are three parts. These three parts are separated by a plus or minus sign. When you divide by a monomial, the easiest way is to separate it into the three different parts, or however many parts you have. So I'm going to take the top and split it up into three different fractions. First I have 4x cubed y squared plus 8xy squared minus 12x squared y cubed. And I'm going to put each of these into a fraction. The bottom part of all of them is the 4xy. So now it becomes three separate fractions that we're just going to reduce each part. So 4 over 4 reduces to 1. X squared over x reduces to x. And y squared over y reduces to y. Plus 8 over 4 reduces to become 2. X over x cancels. Y squared over y is just simply y. Minus 12 over 4 is 3. X squared over x is just x. And y cubed over y is y squared. And that is your answer for that example. Now we will talk about dividing a polynomial by another polynomial. And it says that we are going to use long division. So before we start with this example, I do want to take a second and look at if we have 3 and we are going to divide 63 by 3, just to review this process because I know it's been a while since some of you have done long division. What you do is you look at the 3 and see how many times it takes 3 to become a 6. So I need 2 3's, so I'm going to multiply it by 2. So up here I put my 2. 2 times 3 is 6, and that's what I write down here. Now this becomes subtraction. I draw my line. 6 minus 6 is 0. Bring this 3 straight down. And then I look at the next part. How many times does it take 3 to become a 3? Well, that's 1. I'm going to take this 1, multiply it by the 3. I bring down my 3, and everything cancels, leaving me with nothing. So we can see that 63 divided by 3 is 21. We're going to follow the same process for this problem. Z minus 4 is going to be on the outside. And z squared plus 2z minus 24 is what's inside the division sign. So whenever we do this, we're going to look just at this first character out here. So this z. That's what I'm going to use to figure out what goes up here for my division. How many times or in other words, what do I have to multiply z by to turn it into z squared? Well, z times z is z squared, so I'm going to put z up here. I now have to take my z and multiply it by both parts over here. So z times z is z squared. Negative 4 times z is negative 4z. Again, just like over here, I'm going to subtract. So this is going to be minus. Draw my line. Z squared minus z squared cancels. I have 2z minus negative 4. So that really becomes 2 plus 4, which is 6z. Bring down my minus 24. And then I go back over here and look at this z again. What do I have to multiply z by to make it 6z? Well, that is 6. So 6 times z is my 6z. 6 times the negative 4 is negative 24. So I'm going to subtract these. 6z minus 6z cancels. Negative 24 minus negative 24, that cancels. I'm left with nothing. So my answer is going to be z plus 6. So when I take z squared plus 2z minus 24, divide that by z minus 4, my answer is z plus 6. Now we are going to look at one final example. This says 8x to the fourth minus 4x squared plus x plus 4 times 2x plus 1 to the negative first. Well, as we've talked about previously, the negative exponents. Move this to the bottom of a fraction. So you can think of having this 2x plus 1 in the bottom of the fraction and not being up here. So now you can see that it is division. So I'm going to set up the problem to do long division one more time. So I have 2x plus 1 on the outside. And something that I did not talk about before because it wasn't an issue, inside I need to have all of my exponents in descending order. Since my highest exponent is 4, I need 8x to the fourth. Then I have to go with the next highest exponent, which in this case, 1 less than 4 is going to be 3. But I don't have x cubed. So as a placeholder, I need to put in 0x cubed. Now, this may not make sense at this point, but you will see when we do the long division that you are going to need this placeholder right here. Then I finish following with negative 4x squared plus x plus 4. One other thing that I want to review before we work out this example is long division that looks like this. So I have 14. I'm going to use the 14 to divide 893. Now, again, we reviewed long division before, but what you do is you see how many times does 14 go into 8? It doesn't. So how many times does 14 go into 89? And that answer is 6. So when I take 6 times 14, I get 84. Subtract here. 89 minus 84 is going to be 5. I bring down this 3. And then you ask how many times does 54 go, or sorry, how many times does 14 go into 53? That answer is 3. When you multiply, you end up with 42. I'm going to subtract, and when I do the subtraction, I end up with 11. Now you ask, how many times does 14 go into 11? Well, 11 is smaller than 14. So what we found out when we were in elementary school is that you take 63, and to get the fractional part, you're going to take 11 over 14. And so this answer would be 63 and 11/14. So we may have to use that as we're solving this longer polynomial. So just as before, we are going to look at, if I can get my highlighter, we are going to look at the 2x to see what we need to multiply 2x by to make it each of these other parts. So 2x times what gives me 8x to the 4th? Well, the number part is going to be 4. And my letter part, I have to multiply x by x cubed to get x to the 4th. So when I distribute that to both parts, I get 8x to the 4th, and then I get plus 4x cubed. I do my subtraction. These cancel. And now you can see right here, this is why I need to fill in my 0x cubed. If I didn't fill in the space, I would be trying to subtract x cubes from x squared. So I have to fill in my placeholders with all of my exponents. So I take 0 minus 4, and that gives me negative 4x cubed. Then I bring down the rest of this. So it's minus 4x squared plus x plus 4. Now I ask 2x. What do I have to multiply that by to make it negative 4x cubed? Well, for the number part, 2 times negative 2 gives me negative 4. And x times x squared, gives me the x cubed. So distribute this part, and I get negative 4x cubed minus 2x squared. Do my subtraction. These cancel. Negative 4 minus negative 2 is going to be negative 2x squared. Bring down my x and bring down my 4. And I repeat the process. 2x times what gives me negative 2x squared? Well, that's going to be negative x. So when I multiply negative x times 2x, I get negative 2x squared. And when I multiply negative x times 1, I get negative 1x. Do the subtraction. These cancel. X minus x squared is going to be 2x. Bring down my 4. And then I ask, what do I have to multiply 2x by to make it 2x? That's going to be 1. So when I multiply 1 by 2x, I get 2x. When I multiply 1 by 1, I get 1. When I do the subtraction, my 2x's cancel. 4 minus the 1 gives me 3. I can't multiply 2x by anything to make 3. Not in an easy sense. So what I need to do is come up here. Since the 3 is positive, I'm going to write plus. 3 goes on top of the fraction, just like my 11 did over here. And then I'm going to put on the bottom, just like the 14, I'm going to go out here in front and get 2x plus 1. And that's what goes on the bottom, 2x plus 1. So my final answer to this problem is 4x cubed minus 2x squared minus x plus 1 plus 3 over 2x plus 1. So I know it's not super simple, but using long division and a review of that will help us as we work to divide polynomials by monomials and other polynomials. Thank you, and see you later.